going to is about inverses of relations and functions. Okay, a relation is just a set of points, but a function is going to have an equation to it. We're going to explore both of those today. We are going to be doing some graphing, and we want to be able to recognize what the inverses of functions are, and then we're also going to find the inverse of functions algebraically, okay? So the first thing we're going to talk about are the relations, and what is an inverse relation, okay? So an inverse relation is a reflection of points. Sorry, we're going to move that up. Okay, it's a reflection of points across the line y equals x. Okay, so a reflection of points across the line y equals x. So a lot of times when you guys did reflections in geometry, you did them across the x-axis, you did them across the y-axis, okay, but sometimes you can reflect across the line y equals x. This ends up being equivalent. This is equivalent to switching the x and the y values. Okay, so if you were to switch the x and the y, that would give you the reflection over the line y equals x. We're going to talk about some different notations today. So this line of y equals x is right here. This dashed line here, this is y equals x. And we call this the line of reflection. So this is the line of reflection. Anytime we're graphing an inverse, we are going to put in the line of reflection. Okay, and then this here says f of x. This is our function. And function notation is f of x. And then this is kind of hard to see, but this is going to be a new notation that we're going to be using today. Okay, this is inverse notation. This is the inverse function, and the notation is f, and then it looks like it has an exponent of -1, and this is of x. The way that this is pronounced is just f inverse. Okay, so you don't even say the -1. That's just part of the notation. So we have the function f of x, and we have the inverse of f of x. Okay, so what we're going to do now is we're going to verify the definition of an inverse relation by labeling a pair of points on the example. Well, what are some points that we can see on the example pretty clearly? What are the 2 points you can see? Well, that's on the line y equals x. So let's look at what's the only point really that you can see exactly on f of x. Yeah, you can see this would be 0, 4, right? Okay, so for f of x, you have 0, 4. Okay, that's your x and your y. That's your function. So we'll label this right on there. That's 0, 4. Okay, and then on the inverse, you have this point, which is what? Yeah, 4, 0. Okay, so that's the inverse. So the definition says that this reflection is equivalent to switching the x and the y values. And here you can see very clearly that the x and y are flipped from the function to the inverse. Whoa. Okay, so what we're going to do now is we are going to graph the relation. We are going to connect those points. So we're going to graph the relation that's in the table. We're going to connect the points. Okay, then we're going to graph the inverse, and finally we're going to identify domain and range. Okay, so we're going to start by graphing the given relation. Alright, so you have your set of points, x, y, so 0, 2. We can go by ones here, so this would be 2, 4, 6, 8, 10. I'm just going to label every other one. Okay, so I'm going to graph my points. So I have 0, 2, which is right here, 1, 5, 5, 6, and then 8, 9. Okay, so remember, like I said earlier, a relation does not have an equation. It's going to be a set of points. It tells you to connect the points, so we're going to connect them in order. Okay, so you guys should all have a straight edge on your desk. We're going to use our straight edge. If for some reason I missed your desk and used a straight edge, I did put them up there for you. And again, you're connecting these in order. And then this is what that relation looks like. So I know right now that does not look like a shape that we are used to. But we did graph the given relation. Okay, so now what we're going to do is we're going to find the inverse and graph. Anytime you are graphing the inverse, you are also going to graph the line of reflection. Okay, and the line of reflection is y equals x. Okay, so we are going to be graphing that. We are also going to be graphing the inverse. So when you are finding the inverse, we just talked about inverses mean the x and the y values switch. So if I do that for my table, right, my new x and y, okay, then instead of 0, 2, I have 2, 0. Instead of 1, 5, I now have 5, 1. And then 5, 6 becomes 6, 5. And 8, 9 becomes 9, 8. And there's my new table. Okay, so 2, 0 is going to be right here. 5, 1, 6, 1, 2, 3, 4, 5, and then 9, 8. Okay, and then we are going to connect those points as well, and we are going to graph the line of reflection. So again, we're just going to connect them in the order that we graphed them. When we're done, this is going to kind of look like a banjo or a Guitar Hero. Okay, so the line of reflection is y equals x. That means the y-intercept is 0, 0, so it starts here, and then the slope is 1, so you go up 1 over 1. So your line of reflection is just this line right here. Starts at 0, 0, goes up 1 over 1. That is the line y equals x. And now you can clearly see, here's your relation, here's your inverse. It is reflected over that line, y equals x. Okay, and then we're going to talk about the domain and range of a function. So the domain and range of a relation is going to be related to its table. Do you guys remember yesterday we talked about the domain? The domain is related to what? The x's, yep. So this is going to be the set of x values. Okay, and then the range is going to be the set of y values. Okay, and they're both going to go from the lowest to the highest value in your table. Okay, so we're gonna look at the relation first. So in terms of the relation, the domain, I'm gonna look at my x's, which are in my chart up here. So what's my lowest x value? What's my lowest x value in my chart? 0. Okay, and then it's inclusive, so I do have to put that it's less than equal to. The domain has to do with the x, and then it's going to go up to the highest x value, which is what? 8. Okay, and the reason why this is continuous is because we did connect those points. And then the range is going to be very similar, so the lowest y value is 2, the highest y value is 9, and then for the range, we're going to use the y. Now let's look and see how this is going to be related to the inverse. Okay, so the inverse, now I'm going to be looking at this table. Okay, so my lowest value for x is 2, and my highest value is 9. For the range, my lowest y value is 0, my highest value is 8. Okay, so look at the domain and the range for each of these. Remember that with the relation in the inverse, the x and y switch. So the domain for the relation became the range for the inverse. That's because the x values switched to the y, and then vice versa. Okay, so you should have that relationship there. All right, now we're going to find inverses of functions. Okay, so this was a relation. Okay, now we're going to have actual equations, and we're going to use inverse operations, okay, which is something that you're already familiar with. Okay, you're just going to be solving for the opposite variable than you're used to. So we are going to be using inverse operations to write the inverse of your given function. So there's a step-by-step guide here for what you want to do. You're always going to start by switching the x and the y values. Okay, so you're going to switch your x and your y. Then you are going to solve for y using the reverse order of operations. Do you guys remember what the order of operations is? What's the order of operations? Yeah, the PEMDAS. Okay, but do you know what the reverse order is? SADMAP. SADMAP, right? So first you're going to look for subtraction and addition, then you're going to look for division and multiplication, and then finally you would get rid of exponents and parentheses, but we're not going to have that yet. And then the last thing we're going to do is we are going to write the equation in inverse notation. So when you're writing your final answer in inverse notation, what that means is your final answer is going to have f inverse. Okay? All right, now the equations that we're dealing with here are going to be linear, and when you have a linear function, what's the most common form of a linear function? More. When you guys are writing equations in Algebra 1, they're always in what form? Well, how do you graph linear functions? They have to be in what form usually? Yeah, well, what's slope-intercept form?
Oh.
Yeah, so that's what this is, except instead of y, it's just going to be the f inverse. Okay, so it's y equals mx plus b, but instead of y, you're just going to have f inverse. Okay, and that's because we are going to be graphing the function. Okay, so we want them in that form. Okay. Alright, so the first step is to switch the x and the y variables. Because these are functions, your f of x is going to be your y. So when you switch, it's going to be x equals 3y minus 8. Okay? And then your second step is solving for y. So if I want to get y by itself, what do I do to both sides? Add 8. See? SAD method. Try to add or subtract. So x plus 8 equals 3y. Okay, and then if I want to get y by itself, how do I move the 3 over? Yep, and then when you divide by 3 and you have more than one term, you are going to divide both terms by that. And when you do that, the x over 3, it's 1/3 x so that you can see what your slope is. So your final answer is inverse notation, 1/3 x plus 8/3. Okay, and you can just keep it right as that fraction. All right, let's try b. Okay, so again, this is like your y, so your first step is to switch, so x equals 4y minus 5 divided by 3. Okay, so what do I want to move over first? Yeah, how do you move over the 3? You have to multiply both sides by 3. So if you multiply both sides by 3, you'll have 3x equals 4y minus 5, because the 3's will cancel. And then to get y by itself, we're going to add 5 to both sides. Then we're going to move the 4 over. So when we move it over, we're dividing both terms by 4. And we're just going to rewrite it as our inverse. So 3/4 x plus 5/4. There you go. Alright, so you go ahead and do part C. There's actually 2 different ways to do part C, so you can decide. And then once you finish part C, go ahead and, for example 3, you can find the inverse for example 3. Or if you're feeling good about your graphing skills, you can graph it. And then your final answer should be simplified. So like I said, there are a couple different ways that you could do this one. So once you switch, you have x equals 3y minus 7 here. So one thing you could do is you could move the 3 over right away. If you do that, okay, then you could just have x over 3 equals y minus 7. Add 7 to both sides. X over 3 plus 7 equals y. And then again, inverse notation would be 1/3 x plus 7. Yeah? And then the other way you could do it, which I'm sure many of you did, is what did you do once you got to your first step? Okay, yeah, you could distribute the 3. So you have 3 times y minus 7, which would give you 3y minus 21 equals x. And then just solve for y. So you're going to add 21 to both sides. Now when you divide by 3, make sure you divide them both by 3. And then you are going to simplify. Okay, so this is 1/3 x, 21 over 3 is 7, and then your final answer has to have that inverse notation. Well, I guess I didn't have to write that again, same thing, right? Okay, so either one of those methods are fine. Okay, and then I asked you to start example 3, where you could either graph the function or you can write and graph the inverse. Okay, whenever you are graphing the inverse, just like I said on the front side, you are going to be graphing what? If there's an inverse, what do you have to graph? Yes, the line of reflection, which is y equals x. Asserted relation, line of reflection. Okay, which is y equals x. Okay, and really, when you're graphing that, you think of your slope and your y-intercept. Let's do a quick reminder on how to graph linear functions. Where do you start? You're not always going to start at 0. Yeah, you always want to start at your y-intercept, okay? So graphing linear functions, you're going to start at your y-intercept, and then how do you find your other points? Yes, you use your slope. Okay, so you use your slope to find other points. Okay, so let's go ahead and let's graph this. So I have the y-intercept is -5. Okay, and then the slope is -1/2. So 1, 2, 3, 4. This is -5. Okay, and then I want you to span the graph. So we're going to go down 1 over 2, down 1 over 2. Feel free to sing a song if you want. Yeah, we should come up with a graphing song. And then again, you're going to use your straight edge. Okay, and there you go. So you use your straight edge. It's going to look really, really nice and crisp. Okay, and then we can also graph the y equals x. Well, we'll do that at the end. I want to show you. I actually want to show you what happens. Something special happens. And then we're going to find the inverse. So to find the inverse, same steps as before. It doesn't matter. You can graph it now if you already did it. So you're going to switch your x and your y. So step 1, x equals -1/2 y minus 5. Okay, so you're just solving for y. You're getting y by itself, so we got to add 5 to both sides. We have x plus 5 equals -1/2 y. Now, how do I move over that -1/2? You want to move over a fraction. What do you do? multiply by the reciprocal. So what's the reciprocal? Close? There. Oh, goodness. Okay, so negative 2 on both sides, and then that's going to make y, and then this will be negative 2x minus 10. So make sure that you distribute. I actually want to make that larger. I don't like it when it looks incorrect. Okay, so negative 2x minus 10. All right, so this is also what we are graphing. And again, we're identifying the y-intercept. That's where we're starting, and then we're going to use our slope, which is negative 2, so you can think of it as negative 2 over 1. Okay, so here's my negative 10. Now, if I were to go down 2 and over 1, I'd be off my graph here. So instead of going down 2 and to the right, I can go up 2 and to the left. Make sure that when you do that, you are paying attention to the sign of your slope, because if it's negative from left to right, the line should be going down. So that's just a quick thing you can do to make sure that everything is correct there. Okay, and then when you use your straight edge, everything should line up very nicely. Okay, make sure you put the arrows on both ends. Okay, and then we are going to graph our line of reflection. So if this is 0, 0, right, you can go up 1 over 1. It is going to be this diagonal line. It's never going to change because the equation is always y equals x. Now look and see where this goes. It goes right through the intersection of these two lines. Okay, and that should happen. Okay, so if you graph those right, they should intersect right on the line of reflection. Okay? All right, and then we're going to look at example 4. I apologize for the datedness of this because Juan is buying a CD, and I don't know if that's very prevalent these days. We also are going to add a word to this. So this should say he buys a CD online for 20% off the list price. Okay, not 20% of the list price, because that would be different. Okay, so 20% of the list price. He also has to pay $2.50 in shipping costs. So the total charge is $13.70. What we're going to try to find is the list price of the CD. Okay, and then we are going to write an equation to model the situation. Okay, and we're also going to solve this using our inverse techniques. Okay, so the first thing I think about is if it's 20% off of the list price, how much is he paying of the list price? So if it's 20% off, he's paying 80% of the original price. Do you guys know how we can represent that? Okay, so how do we represent 80%? Yeah, 0.8, and then we'd have to have some variable. We can call it P. So we're going to be using that in our equation. Okay, so let's say, let's make C the total cost. So the total cost is the 80% of the list price plus what he has to pay for shipping, which is $2.50. Okay, and this is where C is the total cost, and P equals the list price. So if I'm writing a equation to model the situation, I can also just solve this for P. Okay, so we're going to solve for the list price. When you are solving with the story problems, you do not have to switch the placement of the variables. You are just solving for the other variable. So we're just going to get the variable p by itself. And for the story problems, you don't necessarily have to get that in linear form. Okay, so we can leave this as the price P is equal to the total cost minus 250 divided by 0.8. Okay, so now that we have this equation, this formula, we already know what the total cost is. The total cost is $13.70, so we can use this equation to find the list price. So $13.70 minus $2.50 divided by 0.8. Okay, so I'll give you a minute to calculate that. What did you get for P? Yes. $14, which is pretty much around what they cost when Miss Ripple was in high school. Okay, so the list price would be $14.